So let's start from Mohr's method of endpoint detection. Now in Mohr's method, it is also referred as a direct method of titration. So when we are saying that it is a direct method, what we mean is our analyte is going to be the halide ion. So let's take an example of titration of say 0.1 molar NaCl solution with 0.1 molar silver nitrate solution. Now NaCl means it is a halide ion solution which is our analyte, and silver nitrate means it is silver ions solution which is our titrant. So as we have discussed in the earlier video also, when we are using silver nitrate as our titrant, the titrations are referred as argentometric titrations. Now this kind of titration where halide ion is our analyte, silver nitrate is our titrant, and we are going to use a particular indicator. In this case, we will be using dilute potassium chromate solution as our indicator. So see here, chromate ions will be behaving as an indicator in this case. So this is an example of a direct titration, and the method is referred as Mohr's method. Now let's look at the reactions going on. So what will happen is NaCl is our analyte. So this NaCl means the analyte ion, chloride ion, will react with the precipitating ion to form AgCl PPT, right? Now once all the chloride ions are finished from the conical flask, what will happen is when the excess drop of silver nitrate will come down, now there are no more chloride ions. So it will react with the chromate ions. So now when Ag plus ions react with chromate ions, they are going to form the PPT of silver chromate, and this silver chromate PPT is reddish brown in color. So ultimately we are going to see a PPT which is colored at the end point of titration, and at that point we will close the knob of the burette, because we know that when the reddish brown colored PPT is being formed means all the analyte is reacted and the excess drop of silver nitrate is now reacting with this chromate ions, indicator ions, to give us colored PPT. So here we can state the underlying principle as formation of colored precipitate at the end point. Now what are the conditions we need to take into consideration? First, this titration has to be carried out in neutral to slightly basic pH. So it is very important that we maintain the pH in the level of 7 to 10. Now why this is important? Because if we go below 7, means if the pH is less than 7, means the solution is acidic. In that case, these acidic means there will be H plus ions present, and these chromate ions, they will immediately react with the H plus ions to form chromic acid. Now they are no more available to act as an indicator. So acidic medium we have to avoid. Now if the pH is more than 10, then also there will be a lot of OH minus, means hydroxide ions present in the basic medium, and those may react with our precipitating ion, silver ion, to form silver hydroxide PPT. So the precipitating ion which was supposed to react with the analyte ion, chloride ion, instead of reacting with this, it is busy reacting with the hydroxide ions and forming the silver hydroxide PPT. So both these cases are not beneficial. So we have to take care that the condition is neutral to slightly basic. How we can do this? We can use a solution of sodium bicarbonate or borax, which will help us to maintain the pH in the required range of 7 to 10. Now we can easily carry out the titrations of chloride and bromide using Mohr's method. But what in case of iodide? See, if I use a solution of iodide ion here, the PPT I am going to get is AgI, means silver iodide, and then at the end point I will have silver chromate PPT, right? The silver iodide PPT is also yellow colored, and silver chromate is also reddish brown, so yellowish shade. So it is not offering a clear contrast. So I cannot identify that my endpoint is reached, where in this case I can easily see. So we are going to avoid titrating iodide ions with Mohr's method. For chlorides and bromides, it is a very suitable method. Direct titration, very easy to perform and gives you satisfactory endpoints. So this is the Mohr's method.